Hello, everybody. This is Mr. Cousage, and we're up to lesson 6-2. Don't forget to put the date here. So 6-2 is matrix multiplication, inverse, and determinants. Okay, sounds very fancy. Matrix multiplication, we know what a matrix is now. What if you had two matrices side by side, right? How do you multiply them? And then the inverse of a matrix. Okay, how do you find the inverse of a matrix? We'll talk about that. And the determinant of a matrix, how do you find that? Okay, so let's get into it. Before we get to the multiplication, let's talk about addition. Addition is exactly what you think it would be. So we're not going to use numbers just yet, but if you had two matrices, right, and you wanted to add them, you do exactly what you think you would do. Okay? You add the first to get the first number here. You add these two to get the next number here, and then these two, and then these two, and you write the answers here. So notice that it only works when they match, when they got the same columns and rows, because otherwise there'll be something sticking out and it won't work. So that's pretty easy. And then you have what's called scalar multiplication, right? Scalar, scale up, scale down. What if you have a matrix and you want to double that? Well, just go inside and double every number. What if you want to take 1/4 of that? Well, just go inside and take 1/4 of every number. What if you want k times that? Then it's just k times every single number in there. Okay? That's scalar multiplication, when you have one number on the outside. It's not a matrix, it's a number on the outside, the matrix. Okay? So what's more interesting is, and we have to slow down, is matrix multiplication, right? So this only works if the two matrices that you're working with are the correct size. What does that mean? Well, it can be any size, right? It can be any size, but this inside number here, so what if A was m times r, then B has to be r times n, whatever that number is. So if your first matrix is, say, 2 by 3, then this number has to be 3 also, 3 by anything. Okay? It sounds confusing, but let me show you an example and you'll get it. So what if I want to, what if I want to multiply these two matrices? So what I'm saying here is one matrix times the other can be done under these conditions. What conditions? Well, it has to match. This number has to match. So notice that you have 2 rows, 3 columns. 2 rows, 3 columns. So this is 2 by 3. This is 3 rows, 2 columns. So this number here has to match. The number of columns has to match the number of rows. Okay? If they don't match and you start doing it, you're going to run into trouble and you're going to say, oh, it doesn't work, and you give up. But it will work if this happens. If you got the same number of columns here and the same number of rows here. Okay? So how do you multiply? It's not intuitive. It's not what you might think it is. It's not just this goes with this and this goes with this, and already you're running out. What does C go with? Right? So it's not that. You don't multiply like that. There's a specific way of doing it. Okay? Don't freak out. So a lot of this you do in your head. So we're doing notes, so there's a lot of writing. But basically, you go, for the first one, you go across and you go down on the second one. So it's this times this, then these two multiplied, then these two multiplied. And those 3 answers get added. One more time. right? This goes across, this goes down. So the first row, first column. Boom, boom, boom. Multiply, 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 add the answers. That's what this says. AG, BH, CI. That's what this says. And then add the answers. Now, we want this position. So that would be the first row, second column. Boom, boom, boom. Right? Like that. AJ, BK, CL. That's what this is. And you add those answers. Moving on, I want this answer here. Well, that would be the second row, the bottom row, first column. The bottom row, first column, we haven't done that yet. So boom, 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 add the answers. Then the last one, multiply, 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 add the answers. Okay? Notice that you started with a 2 by 3 and a 3 by 2, and you ended up with a 2 by 2, 2 rows, 2 columns. Those are the end numbers there. Okay? Again, if this wasn't a 3 by 2, if it was, say, a 5 by 2, right, 5 rows, then you'd run into trouble. Because if there was more rows down here, you'd go boom, 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 and then there'd be nothing to multiply with down here. So it wouldn't work. So as you go across and as you go down, they have to match. Okay? All right, so where's my example? Here's an example, right here. Okay? Here's an example. So I want to multiply matrix A times matrix B. What is A times B? Okay? So remember, across, down, right? So boom, boom, add those answers. Next one, boom, boom, add those answers. Next one, boom, boom. So I'm done multiplying with the first row. So it's really the first row, it's kind of like distributing. The first row times this, times this, times this. I'm done with the first row. Then the second row, right? Times this, times this, times this. Okay, ready? So, what do we got? 3 times negative 2, negative 1 times 3. There it is. And I add the answers. 3 times 0, negative 1 times 5. There it is. And then add the answers. 3 times 6, negative 1 times 1. There it is. Add the answers. Now we work with the second row. 4 times negative 2, 0 times 3. There it is. Add the answers. 4 times 0, 0 times 5. There it is. Add the answers. 4 times 6, 0 times 1. There it is. Add the answers. Right? So now you go back. This is what? This is negative 6 plus negative 3, which is, right? I took an extra step. Negative 6 plus negative 3. This is 0 plus negative 5. This is 18 plus negative 1, etc. Negative 8 plus 0, 0 plus 0, and then you do the addition, and there you go. This is the answer. This is the answer to the multiplication of A times B. This is it. Now, if you can do some of it in your head, okay, but I suggest you write everything down so you don't make a mistake. This is the answer to A times B. This matrix times this matrix. Okay? How about this one? Well, I kind of wrote down what happens on the side there. I want to multiply these, but look, this is what I'm talking about. This one won't work. So here's the first row, here's the first column. This times this times this, and there's nothing to multiply with the 6. There's nothing down here, right? So that's why they got to match. Number of rows, number of columns has got to match, right? Boom, boom, nothing there. So it can't be done. Leave it alone. No solution. Okay? Okay, what is an identity matrix? Identity matrix is like the 1 for the matrix. Like we have 1 in regular numbers, And it's called identity because it doesn't change anything when you multiply. Like 5 times 1 is 5, 6 times 1 is 6. Well, what is the identity matrix that when you multiply it to a matrix, it doesn't change it, it keeps it the same? What do you think it looks like? Well, it should have ones in it, that's for sure, right? Well, it depends on what size you need. If you need a 2 by 2, it looks like this. If you need a 3 by 3, it looks like this. 4 by 4, 5 by 5, etc., etc. So what it looks like is it has ones on the diagonal, every other place 0. Okay? So if you multiply any matrix with one of these, right, with the identity, you're going to get the same matrix back. That's why this is called the identity matrix. Okay, so for example, if I multiply A times, so A can be any matrix, I is reserved for the identity matrix. So if I multiply A times I should get A back, right? Okay, so let's make, for example, A equals 1, 2, 3, 4. So if A is 1, 2, 3, 4, then I have to choose this size, right? This size won't work. So when I multiply these, I should get the same thing back, right? Because this is the identity matrix. Okay, so here we go. Right? Boom, boom. 1 times 1, 2 times 0. 1 times 0, 2 times 1. I'm done with the first row. Next row. 3 times 1, 3 times 1, 4 times 0. 3 times 0, 4 times 1. Right? I wrote them down here. That's what I just said. So this is 1 plus 0. 1 plus 0. This is 0 plus 2. Right? This is 3 plus 0. This is 0 plus 4. And look, this is 1, this is 2, this is 3, this is 1, 2, 3, 4. I started with 1, 2, 3, 4. I ended with 1, 2, 3, 4. That's what happens when you multiply with the identity matrix. Okay? So now you know what an identity matrix looks like. Depending on the size you need, it's the ones on the diagonal. All the other spots are zeros. Okay? So for this part of our lesson, we're done with part 1. But can you try multiplying this in your notes, and I'll give you the answer next time I see you. So multiply A times B, and then switch them, right? B times A, if possible, right? Remember that one example where it couldn't be done? So if it can't be done, if one direction can't be done, then it can't be done. Leave it alone. So go ahead and multiply this times this, then this times this. Oh, okay. So I'll leave you with that, and we'll move on to part 2. Okay, this is the end of part 1. All right, see you later for part 2.